practice exam number 1. So here we go. Oh, we're not seeing anything. I keep forgetting. So there's number 1. So we need to do something with this thing. Can you see it okay? I can make it bigger. So let me do that. So 1/3, I don't know if there's enough room to make it much bigger. 1/3, 12x minus 15 minus 1/5 minus 30x plus 35 minus 13. Okay, there we go. All right, so what do they say? They say simplify by removing parentheses and collecting like terms. So we need to simplify this thing. So what are we going to do to simplify this thing? I'm going to take this 1/3, I'm going to go boom, boom. Right? Anything outside of parentheses, you multiply into the parentheses, huh? So put that on in there. And do you know what to do with that? And then the 1/5, same kind of thing. Let me give you a second. All right, so let's distribute that 1/3 through there. So basically it just divides, right? 12x divided by 3 is 4x. 15 divided by 3 is 5. It's making sense so far. See what I did? I just divided each of those by 3. And now the minus 1/5 is going to go in there. Watch your signs carefully. Minus times minus plus 6x, yeah. Because 30 divided the 5. Right? Things in the bottom divide, don't they? Right? Next one, minus 1/5 times plus 35. Negative times positive? Negative 7. Minus 13.
You divided because it's a fraction, right?
Right. Because that's what a fraction means, huh? The bottom of a fraction means divide. Exactly. Is that good so far? Now what do we do? That's it. There it is. 4x and 6x. 10x. And then just use your calculator. Minus 5 minus 7 minus 12. It's minus 25. And there it is. Option D.
All right, now let's get to 2 because I actually have a question.
That good for number 1?
Yeah.
All right.
I wouldn't have done
All right, let's get right to number 2. So 3m to the minus 6 over 7m.
Did we actually go over these?
Seems like a foggy memory, huh? Yes, positive, negative powers. All right. So what do we do on this problem?
You flip them. Put the...
We can't
Yeah.
do negative.
Yeah, right. Negative powers. What are negative powers? Remember my little goofy analogy?
There's no such thing because they turn into half fractions.
I don't remember making that analogy.
You had 2 over there.
Negative powers are negative. They're unhappy where they're at. Like to being unhappy at your job. They switch jobs.
You go 1 to the 0 power, and then it goes...
Right, so that's something a little different. We'll get to that. But negative powers are unhappy where they're at, and they want to jump to the other side. So this whole 7m, which has a negative power on him, he's like, I don't like it down here. He's going to jump up. And then this guy has a negative power on him. He's going to jump down. And after they jump, they're happy. So 7m now to the positive 7. 3m now to the positive 6. So far, so good? So negative powers are negative. They're unhappy where they're at, and they always want to jump to the other side. We have another step still to go, but so far, so good? Now, well, let's finish before I ask other questions. We'll keep going. Now, what does this 7 power do when he's outside of parentheses? He multiplies in. Becomes 7 to the 7, m to the 7. Same thing with the 6. 3 to the 6, m to the 6. So far, so good. The parentheses are gone, huh? When something from the outside of parentheses goes in, the parentheses drop off, don't they? So that parenthesis just dropped off. Both those parentheses did. And we can do one more step. Look over here at the answers. We're not quite matching yet. What do we got left to do?
Do the powers of the numbers that are up there.
Do what's that?
The powers of the numbers that are up there.
Yeah. So the powers for the m's specifically. We're going to do those two, right? These guys right here. Because that's 7 m's on the top. And there's 6 m's on the bottom, right? You know what m to the 7th means. It means 7 m's, doesn't it? 4, 5. I can't write them. There we go. Okay, there's 7. And the one on the bottom means 6 of them. 3, 4, 5, 6.
Subtract them?
So they're going to cancel. How many are going to be left over, and where will they be left over? One on the top, huh? You really just subtract the powers, don't you? Yeah, so we're going to end up with 7 to the 7th and 3 to the 6, are going to stay where they're at. They're good. They're not doing anything else. But the m will just end up with 1 m on the top. Is that answer there?
No, because you have to
It's not there?
do 7 to the 7th and do...
Yeah. So there's nothing else. It's none of these. It's none of these, right?
I told you someone was going to get in trouble on that one.
That's kind of disturbing, isn't it, to get a none of these like that? Okay, so that's part of what I want to do on practice exam day. Remember, because my big goal is to not surprise you. I want to fairly test what you know about math. So no surprises. There will be some none of the aboves on the exam, every exam you take with me. And people, I think maybe I've told you already, it's been years now. Every exam, I hate your none of the aboves. I know you hate them. But I want to let you know they will be there, so there's no surprises. There won't be like 10 of them, but there'll be like 3 or 4. So 3 or 4 will be none of the above. I will use that option. That way I know you're not just guessing your way through. You really know when it's there, and you really know when it's not. So don't be disturbed. They're there. Okay. But you don't have to. Does this mean 7 times 7 times 7? Yeah, it does. But you don't have to do it if they left it that way. Okay. You just got to do whatever it takes to match.
But wouldn't the answer still be the same if she...
It would. It would.
Because when you do what she's asking, it still would not be.
Right. It still wouldn't be there. So there it is. None of the above.
That was the question that I had. I was like, wait a minute.
It's not there.
I was like, it's not there anyway. It's like, how far does it want to go?
All right. How about this one? 4x to the 5th times 6x to the 5th over x squared.
I have a question while I was doing this homework. Is it best to not...
Feel free. All right, so I'm going to crank it out. 4 times 6, 24. And what do these powers do? They add x to the 10th, right? Because this means 5 x's and this means 5 x's. We got 10 x's up there, don't we? Down below, we got 2 x's and 2 x's. How many x's we got? 4 x's. And now, what can we do with the 10 x's and the 4 x's? Yeah, and that's what Dennis was seeing. He was just looking at that going, right, I'm assuming that's what you're doing, just going, hey, 4 and 6 is 24, and subtracting the x's, that's great. And there it is, 24x to 6. Yeah, so you don't have to write it. I'm not even going to ask you to turn in your work. I'm just going to ask, I'll see your work, but I'm only going to grade the multiple choice answers, and then the last 2, I will grade your work, because those are not multiple choice. We'll see. But yeah, do whatever you want to do. In the end, grab the right answer, and it's all good. I don't care what method you use. How about number 4? Very similar. Okay, what do powers, let me write a note for you. Powers outside parentheses. Do you know they multiply powers inside parentheses? So powers outside parentheses multiply powers inside parentheses. So this 3 will multiply that -5 to be -15. Good so far? And the parentheses go away, don't they? When something from the outside of parentheses goes in, they drop off. And so down below we have x squared. Okay. And x squared, that's x to the 4th, right? That's just 2 x's and 2 x's. So far, so good? Got some more steps to go, but is that okay so far? Is that making sense? Now, what are we going to do about this guy? Is he happy?
No.
He's negative. He's unhappy where he's at. So what's he going to do? He's going to jump down. You go left side, right side, doesn't matter. What about the guy in the bottom, this x to the 4th? Is he happy? Yeah, he's good. He's not going up. On the other one, the one back here, they both jumped. See how they both had negative powers back on number 2? So they both jumped. They were both unhappy where they're at. Not so on number 4. Only the top guy's unhappy. So only the top guy's going to jump. And then after he jumps, his power becomes positive. And the x to the 4th, he's been good all along. He's not going anywhere. He stays put. Well, there's nothing left on the top. What do we do when there's nothing left? You just go 1, huh?
But there's always something on the top, so that's the middle.
That's right. And so then, what do we do with this right here? How do you combine them? This means 15 x's, and this means 4 more x's, right? You add them up. 19 x's. There it is. How about number 5? X over 5y to the negative 4. So, what's our first step? What was the rule I wrote right here? Yeah. So I got a power outside the parenthesis. So he's going to come in and multiply that power. And multiply that power. We're going to get x to the minus 4 over 5y to the minus 4. Is that correct the way I've written it?
No.
No, it's not. I hope you know it's not right. Why not? Didn't I do it? I missed the 5. He's a player too. Right? They all have an invisible 1 power, even the numbers. So the 5 needs his own negative 4 power. That's the common mistake. I'm just showing you the common mistakes I've seen students make over all my years of teaching. I can almost call them out ahead of time. So watch out. I'm showing you what to watch. I'm showing you the traps and the tricks that'll get you. So remember, a power outside parentheses needs to multiply all the powers, all the invisible ones, and everybody has an invisible one, even the numbers.
So then everything's going to flip?
That's right. Everybody's unhappy, huh? Everybody is unhappy where they're at. This guy's unhappy, he's going down. These two guys are unhappy, they're going up. And after they jump, then they're happy. They like their new job. So 5 to the plus 4, y to the plus 4, x to the plus 4. And now you can leave it that way. Remember that other one back here? We just left the numbers with the powers and we didn't mess with it. And why? Because that's what they did. So remember, on a multiple choice test, you're just trying to match up, right? So I just look over and go, what'd they do? Oh, they left them all, so I'll just leave them all. Whereas on this one, I look over and I go, oh, look, they got some 625s. So I bet you, if I take that thing and take my handy-dandy calculator and I go 5 times 5 times 5 times 5, I bet you I'm going to get a 625, right? That's all this means, right? We good with that? 5 times 5, 4 times. So that's going to be 625 y to the 4th over x to the 4th. Which answer is that?
B.
Yeah, it's B, isn't it? There it is. It is B.
I have a
Question.
Can you do it all the way out and put the 625 y over?
How do we handle these root ones? What do we got to do?
The 72?
Yeah, take your calculator and break down the 72. Find out what multiplies. So it's 9 times 8. Just use your calculator. And then that's 3 times 3. It's 2 times 4. 2 times 2. So it breaks down to be what? 3 2s and 2 3s. So what do we get here? We get 5 root of 2 3s, 3 2s, x to the 11th. I'm just going to write those out. 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, I sort of squeezed them in. And 4 y's. All right, you don't have to write them out, but it didn't take too long. All right, so now what's the rule for roots? 2 for 1 deal, right? Remember, it's a 2 for 1 deal. So square roots are a 2 for 1 deal, right? That's what we've talked about. Remember, like if I gave you down here square root of 9, we all know that's 3. And what just happened there? What's in a 9? 2 3s. See how those 2 3s in just led to 1 3 out? Square roots are a 2 for 1 deal. They're like shopping at Target. Things are on sale 2 for 1, right? So you come back here and you go, okay, 2 3s inside, 1 3 outside. It's going to multiply that 5 that's already out there. 2 2s inside, 1 2 out. And they're gone once they ship out. 2 x's inside, X outside, another 2, another 2, another 2, and a last 2. And 1's left over inside, if you can see my little scribbles. There's 1 X left over inside. How many are coming out? 5 of them, because there were 11 to begin with, right? If you're shopping at Target and things are on sale 2 for 1, you're buying 11 items, you're going to pay for 5, and the other one has to stay in, right? That makes sense. You can just divide by 5. Divide by 2. That'd be quicker. So what comes out? 5 times 3 times 2. That's 30. X to the 5th. Now we got to finish the y's up. 2 y's in, 2 y's in. Y squared's coming out, right? 1 y from that pair, 1 y from that pair. So y squared's coming out. What's left inside?
2x.
Yeah, this 2 right here, this leftover 2, and this leftover x that couldn't pair up. There we go. Does that make sense? Everybody see that?
Yeah.
Okay, so we got 30 x to the 5th y squared, root 2x. It was number 30 x to the, oh, this is close, but not right. No, it's none of these. Again, sort of disturbing, right?
But if that's the answer.
At least we did all the work, so that's a good one.
All right.
Thank
All right, on we go. Let's try this one. All right, so 250, we got to break that down. 25 times 10. Things that end in a 0 are times 10, aren't they? And then the 25 is 5 times 5. The 10 is 2 times 5. All right, so we break down that 250. It's just 3 5s and a 2. It's kind of nice. So we say, all right, cube root 3 5s and a 2. And then a whole bunch of x's. 14 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I put them in groups of 3 as I counted them out because I know I'm going to be shipping out 3 for 1, right? The 3's in the hook. It's a 3 for 1 deal at Target. So here we go. 3 5s inside, 1 5 outside, and they're all gone. So the number in the hook tells you the deal at Target, right? You got a 3 in the hook. It's a 3 for 1 deal. And then 3 x's in, 1 x out, 3 x's in, 1 x out, 3 x's in, 1 x out, 3 x's in, 1 x out. All right, so what made it out of the root altogether? 5, and how many x's? X to the 4th. Cube root of, and what's left over hanging out inside the root? This extra 2 and these 2 extra x's. So 2x squared, right?
Wait, don't you multiply the 3 and 5?
This 3 is in the hook, not in the front.
The other one was out.
Yeah, good question, good clarification, right? This last one, see, this 5 was sitting in front. He wasn't in the hook. So he multiplied whatever came out to join him. See that difference? Whereas this 3, he's in the hook. He's just directing the deal at Target. He's not multiplying anybody. He'll still be in the hook all the way to the bitter end there. Or the happy end. Maybe it's a happy end. There we go. So the 6 is just 2 times 3. That's not going anywhere, is it? There's not 2 of anything there. 216, 2 times 108, 2 times 54, 6 times 9, 2 times 3, 3 times 3. So we got 1, 2, 3 2s and 1, 2, 3 3s.
Wait, I did that.
How many 2s did you get?
3 2s and 3 3s.
Yeah. Oh, interesting. So even though I multiplied it differently, I'll still get the same answer?
That's right. There's actually a rule called the fundamental theorem of arithmetic that says it'll always be the same, no matter how you break it down.
Because I did 72 and 3.
Yeah, no matter how you do it, if you go all the way down to primes, there's only one unique identity. It's like a DNA for the 216. There's only one way of making 216. And I lost that x. Careful not to lose that x.
Oh, thanks.
And then now the 6, or I mean the 150. Let's break that down. 15 times 10, right? Anything ending in a 0 is times 10. 15 is 3 times 5. 10 is 2 times 5. So what do we got here? 2 times 3 times 5 times 5, and then the x. So we good there. That's the most part. That's the lion's share of the work there as we
And don't
break
forget
them all
that-
down.
Don't forget that X.
Yep, don't forget that x at the back. All right, so now let's do the ship out. Right? There's nothing in these hooks, so that means it's a 2 for 1 deal. So 2 2's in. Oh, you know what? And the thing I would do if it was my test on the line, I don't like to mess up. All right, so let's start shipping stuff out. So check with your calculator, multiply these all together, make sure they're really 216. Multiply these together, make sure they're really 150. That's the one quick, easy thing you can do to really save yourself errors. Just remultiply them, make sure they're right. All right, 2 2's in, 1 2 out, 2 3's in, 1 3 out. So that 2 times 2 times 3, what's that, 12? Will come out. What's left inside? 2 and a 3 and an x, right? 2, 3, x, 6x. And then this other one, 2 5's in, 1 5 out. 5 times 6, 30. What's left inside? 2, 3, x, 6x. We good there? Now notice all the roots match. So we can combine them. They're like roots. We can combine them. So in other words, what number's really right here in front of this root? 1 is an invisible understood 1. So 1 root of 6x, take away 12 roots of 6x, take away 30 roots of 6x. Use your calculator. Minus 41 roots of 6x. Hopefully that answer's on there. Start by breaking down that 44. Start by breaking it down. 4 times 11. And the 4 is 2 times 2. Right? And then we can ship some stuff out of there. Right? So we have 2 2's inside. We're going to ship 1 2 outside. Is that good? So do that first. Square root of 5 over 2 root 11. Get that out for you. So never leave a root in the denominator. We can't leave a root in the denominator. So what is it that's going to get rid of that root from the denominator? Yeah. Just by the root 11. You don't need to use the 2, huh? Just the root 11.
So don't leave the roots in the ground.
Good, well said. Just like when you're pulling weeds. Don't leave the roots in the ground. You good there? So, okay. So now we multiply straight across the top. What happens when we multiply across the top? Root 55. Yeah, let me let you finish. Let me help with that. So, maybe I can help with this. What is the root of 11 times the root of 11? It's a plain 11. Remember what we learned about roots? They're shopping at Target 2 for 1 deal. So 2 11's in is 1 11 out. Right? 2 11's in is 1 11 out.
Yes.
Remember what we've learned about roots? Is that good? Right, they're a 2 for 1 deal. So what? Okay, let me make sure you're making that. What's root of 7 times root of 7?
7.
Plain 7, because again, 2 7's in, 1 plain 7 out. Not in a root anymore. Right? Remember, that's the fundamental rule for roots. 2 in, 1 out. Right? So down here, root 11 makes plain, those two make plain 11, and then 2 times 11, 22. And there's our answer. Bless you.
That number out.
Yeah, so whenever you break, like if you broke 8 down, it'd be 2 times 4, and the 4 would be 2 times 2. So the 8 would be 2, 2, 2. And so 2 2s would send one out. Yes, you have to do that. They're gone, but that other one would stay in, right? This guy stays in. Does that make sense? Yeah, so anytime you have 2 of anything, you send one of those out and they're gone.
Which basically is a square root.
That's what a square root
That's
does.
what we're breaking out, basically doing.
Yep,
So
exactly.
if we had 2 7s in the thing, we would take the 2 out. But
That's right. That's the fundamental rule of roots. 2 for 1 deal.
we just been breaking it down like that. We never really covered why.
We good? Other questions on this one? At the root of 81 over 28. Same kind of thing. See what you can do on this one.
You still have 49 that's out.
Okay, so what's the square root of 81?
9.
Yeah, hopefully you know that one. You recognize that one. You can check it on your calculator. Square root of 81 is just 9. No more root up there, right? He did his root and he's gone. But the root is still on the bottom. You can't square root 28. You got to break it down. That makes sense? What I just did there? So the square root of 81 is 9. Do you see why there's no more root on the top? Because we rooted the 81 and it made 9 and it's gone. Now the bottom, 4 times 7, 2 times 2. So that's 2 2s inside. Sends 1 2 outside. What's left inside?
7.
That's 7. So we've got 9 over 2 root 7. Can we stop there? No, what's wrong with it?
It's on the bottom.
Got a root on the bottom, huh? So what do we do when we have a root on the bottom?
We root it. We transform it into a positive whatever.
Multiply that root top and bottom, huh?
Yeah.
Right? Because it's okay to multiply the same thing top and bottom. You're not changing the fraction. Okay, so then what do we have? Well, this goes straight on the top, just 9 root 7. We're fine with a root on the top. We don't care about that. No problem there. What happens on the bottom, though? We got the 2.
And now we have the 7 right next to it.
What's root 7, root 7?
7.
1 plain 7, isn't it? No more root, which makes 14.
So you leave the 9 and 7 like that?
What else could I do with it?
I thought you had to
Yeah, now can I cancel 7 into 14?
No.
No, because there's a big long bar on it. Wait, no.
Why can I not? The answer is no. Why not?
A big line right there says you cannot pass.
They're in different worlds, right? He's in the root. He's not in the root. They live in different worlds. So no crossing the line. There's 2 different worlds there. In the root world or out of the root world.
Funny.
Yeah, right. Yeah, so what do you do with this minus that's in front of the parenthesis?
The long bar.
Yeah, he needs to distribute to all of them, doesn't he? Anytime you have a minus in front of parentheses, he distributes to all those in the back. The first parenthesis is just going to drop off. There's nothing in front of the first parenthesis, so nothing changes for him. But the one at the back, the signs are all going to change, aren't they? Because a minus is hitting them all. It's going to become plus 10 into the 4th minus 7 into the 7th minus 11. Does everybody see that? So that minus sign went boom, 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 and hit all 3 of those, changing all 3 of those signs. Now there's no more parentheses. Remember, when things from the outside of parentheses go in, they drop off. So now we combine like terms. So 9 into the 7th, take away 7 into the 7th. 2 into the 7th. 14 into the 4th, and 10 into the 4th. 24 into the 4th. Is that good? And finally, plus 3 minus 11, minus 8. Are we doing that good? Number 12 is 3x minus 8y to the second power. And so what do we do when there's a 2 power on something like that? On parentheses. What do we do with a 2 power on parentheses? Two of them, right? So we write 3x minus 8y and 3x minus 8y. We write two of them. And then we take the first to both. And when that's done, we go second to both. Can you crank through that? Okay, so then that becomes 9x squared. 3x times 3x is 9x squared. Remember, out front numbers multiply, powers add. What powers? The invisible 1 powers on those x's. Out front numbers multiply, powers add, minus 24xy. He's done. And now the minus 8y goes to both. Remember how that works? First to both, second to both, also called FOIL. First to both, second to both, minus 24xy plus 64. 8 times 8, 64, y squared. Okay, now, these two in the middle are like terms, aren't they? So they'll combine together. Minus 48xy. You don't make it x squared, y squared with the 48, because when you're adding, subtracting, you just do the numbers in the front. You don't mess with the letters. Whereas when you're multiplying, you add the powers. Don't you see that difference? And so there we go. There's the answer on that one. So hopefully that one's there. Looks like it is. 2. So go to all three. So 2y times negative 3y squared is negative 6y to the third. Remember, out front numbers multiply, powers add. The y to the 1 adds to the y to the 2 to be y to the 3. Out front numbers multiply, powers add. Plus 2y times minus y is minus 2y squared. And plus 2y times minus 2 is minus 4y. And now he's done. And now it's the 9's turn to go to all three. So minus 27y squared minus 9y minus 18. So now let's bring down minus 6y cubed minus 2y squared minus 27y. Now the multiplying's over at this point, right? The parentheses have dropped. The multiplying's over. So now let's combine like terms. Minus 2 and minus 27 is minus 29y squared. Minus 4y and minus 9y makes minus 13y, right? If you lose $4, you lose $9, you lost 13. And then the minus 18 drops down. There we go for number 13. Whip it out here. So the x goes to both. So we get x squared minus 2xy. He's done. So that x went to both. And the minus 2y goes to both. Minus 2xy plus 2 times 12, 24y squared. Do you understand that? Minus 2y times minus 12y. Two negatives make positive. 2 times 12 is 24. Powers add on that. Oh, did I mess up?
12 instead of 2x.
Oh, there should be a 12 here. Did I mess anything else up? That it? Thank you. I was testing you. Right. Good. Thank you, Lily. Yeah. All right. Good? Better? And what can we do from there? Yeah, these two in the middle, they're combinable because they're like terms. Minus 14xy plus 24y squared. There we go. I'm going to make it an x. It's x squared minus 2x. It's actually a u in the problem. I'm using x. Minus 35. And they ask us to factor this one. In fact, actually, it might be helpful just to go back and see it. Yeah, there it is. So I'll make it an x, but same thing. X squared minus 2x minus 35. Factor. So we're changing gears. We're factoring now. See the answers here? So it'll help you. It's kind of nice having the multiple choice. You know, I like it to give you a little bit of help. You see the parentheses and you go, oh, okay, I got to like do the double parenthesis thing. And it kind of gives you a little guidance. So see if you can crank that out. So you can see that we got to do the two parentheses, right? Remember, the front times the front makes the front. And the last times the last makes the last. What times what makes 35? 5, 7. Now, how do the signs go? Remember the rule? Sign in the middle always goes on the bigger number. So the bigger number is the 7. So the sign in the middle has to go on the bigger number. Now, the smaller number can be plus or minus depending on what it takes to make the middle correct. But the sign in the middle always goes to the bigger. So it's -7 for sure. And what does the 5 need to be, plus or minus, to make the middle -2? Positive, right? Because you gotta lose $7 and gain $5 to have a -2 effect, a loss of 2. Right? So that's right. And they have that. D it is. Here it is. That makes sense. Questions on that one? All right, let's try. So number 16 here. 2x squared plus 2x minus 24. So this is where multiple choice really kind of helps you. Look at the options first. See how a couple of them have what in front? A 2. So we're thinking, oh, you probably got to take out a 2 first. Right. So use that for your advantage. Take out a 2 first. Okay, so here's another mistake I've seen several times over the years. People will look down here, they'll go, oh, yeah, I see, I got to take a 2 out. I see. So they'll put a 2 in the front, and they'll go right to the 2 parentheses. No, that's the final answer. Will look like that, but there's an in-between step. Remember, whenever you take out a GCF, you've got to do the one big parenthesis step first, and then the next step will go to the 2. Remember that? You can't skip that step. Well, unless you're just super good and you can just see the whole thing in your head. But for most people, you don't want to skip that first step. Remember, whenever we take out a GCF, we have one big parenthesis. If you look back in the notes on that section, I was always writing GCF, one big parenthesis. So you got to have one big parenthesis first. They're just kind of looking at the final answer, I think, and trying to jump right to it. And then they're all confused why the numbers don't seem to work. You can't skip the one big parenthesis. So take that out. Try that first. So what goes on the inside? 2 times x squared, 2 times x, and 2 times minus 12. Okay, good. And now we say, okay, front times front to make front. What times what makes x squared? X and x. And last times last to make 12. 6 and 2, 3 and 4. How do we know what we want? The middle has to be 1. Right? We're going from here. Don't go all the way back to here. We're now working on this step. So it's going to be 4 and 3. That makes sense? See what we're trying to do? We're trying to go back to this middle term. We want them to multiply to be 12.
And subtract to be 1.
Right. So notice I put down the 4 and the 3 first. Now what signs do they need? How do we decide the signs? Sign in the middle always goes on the bigger. Always. The other one can be plus or minus depending on whatever works. What does the other one need to be? Negative, because 4 minus 3 would be plus 1. And there we go. So which one of those has that answer? It's D, isn't it? They put the x minus 3 first, but that's totally fine. It doesn't matter. We good there? So 384 x squared minus 54. So you can look. It's nice to have the multiple choice. Looks like what number is probably supposed to come out front? They took out what number? 6. So definitely try to take out a 6 first. And now how do you figure out what goes here? Just take that 384 and then just divide it by 6 on your calculator. And it'll tell you what needs to multiply to go back. And I don't know what it is. 64. X squared minus, and then divide this one by 6, 9. Again, if you multiplied that 6, it would go back. Does that make sense how we came? We're not done yet, but that step making sense so far? So I just looked at what we had. I saw the 6's, and I was like, oh yeah, probably take out a 6. Divide them by 6, find out what's left. Now what can you do with that? 64x squared minus 9? Remember, that's a difference of squares, double-double I call it sometimes. Right, you leave the 6 there, you do the 2 parentheses. Front times front to make front. What times what makes 64x squared? 8x, 8x. And last times last to make 9. What times what is 9? 3 and 3. And how do they make negative 9? 1 positive, 1 negative. So that's right here. On that. That good? Questions on that one? All right, number 18. It's 25x squared minus 20x plus 4. Notice, look at the answers. Let them help you a little bit. There's no numbers in the front of any of them, huh? So there's no GCF here. And so just go right to the 2 parentheses. And you can let them guide you as to what to kind of guess at, huh? They're kind of helping you out there. Seeing that? So front times front to make front. So that's going to be 5x and 5x to make 25x squared. And, right, good so far. And then last times last to make 4. What times what makes 4? 2 times 2 makes 4. Okay. But 2 and 2 don't make 20. Remember, these are the harder kind. When you have a number in the front, you have to check. Meaning you have to take the first one and go to both. No signs yet. No signs. 25x times 5x. 25x squared. 5x times 2 is 10x. And then the 2 go to both. 10x and 4. Do you see how I'm checking it? Right? I'm taking the first to both, second to both. So that's how I got those 4 terms. And now I ask myself, okay, how can the middle 2 here make the middle here? What signs do they need? Both negative, right? Because you lose 10 and lose 10, you lost 20, huh? And that means, remember these signs crisscross? This one goes here. Of course, it doesn't matter. They're both the same. This one goes here. So, is it there? Answer 18? That's the same thing, right? 5x minus 2 with the 2 power. That means 2 of them. There it is. Questions on that one? All right, I'm going to jump in. So you can tell there's no GCF. 2 parentheses. Front times front to be 15z squared. 5z, 3z. Either order doesn't matter. Order on the front 2 doesn't matter, but the order on the back 2 will. Okay, now on the back times the back to be 12. Probably 4 times 3. So how about 4 here and 3 there? Is that a good plan? There's a reason I've told you that there's no way that's true.
No, because if you do it that way, that means you can factor it out. That's all.
Yeah, never have 2 numbers in the same parenthesis that have anything in common. Remember that? Let alone are the very same number. Remember that rule? So you're never going to have two numbers in the same parenthesis that have anything in common, let alone are the very same number. So it can't. So if it is 4 and 3, it's the other order, isn't it? The 3 would have to go here, and the 4 there. See, that way 3 and 4 have nothing in common. 5 and 3 have nothing in common. That just may work. No guarantees, but for sure the other one isn't right. Is that good? So now, how do we know if it's right? Check it. You gotta check it. So take the 5z to both. 15z squared. 20z. Take the 3 to both. 9z and 12. Okay, so these middle two are supposed to make the middle minus 11z. Remember how it works? The sign in the middle goes on the bigger, right? That minus sign there in the middle goes on the bigger. And then the other one, the 9 can be plus or minus. What does he need to be to make the middle minus 11z? Needs to be plus, right? Right? If you lose $20, you gain back 9, you lost 11. That's good. Okay, now how do the signs go into the parentheses? Crisscross. This one goes there. This one goes there. Remember that? They crisscross, and we got it. So is the answer there?
Yes, it should be.
See? There it is. So that just takes practice. Practice on checking those, multiplying those out. I'm going to keep moving. 20. Factor completely. So, 4 terms. So that's what's special here. So 6x cubed plus 8x squared minus 15x minus 20. How do we deal with 4 terms? Remember what we do?
Same thing we've been on.
2-2 split. Remember, you do the first 2 and the last 2. Separate groups. First 2, last 2. You factor just the first 2. You factor just the last 2. So take out what's in common from just those first 2. What do these guys have in common? So step 1, you do a 2-2 split. And you do GCF for those guys. Okay, so what's in common? What goes into 6 and 8? 2. And what power of x do you take out? The lower one. Yeah, because that's what they have in common. What goes on the inside? Whatever works. So 2x squared times
1x.
3x. And 2x squared times 4 will go back, won't it? Right? 2x squared times 3x. Out front numbers multiply, powers add. Right? So that 1 power and 2 power will add to be 3. 2 times 3 is 6. And 2x squared times 4 is 8x squared, right?
Yep.
Now, here's the second. Well, okay, now we'll go to the next pair. What does this next pair have in common? What goes into 15 and 20? 5. And you bring down whatever sign's in the middle. Minus 5. Now, good so far? Before I do those parentheses, let me remind you of step number 2. Remember? The parentheses are always the same. That helps a lot. So 3x plus 4, it's got to be 3x plus 4. You can double check it, but it's got to be. Minus 5 times 3, yeah. Minus 5 times 4, yeah. So that is when you're doing 4 terms. You can totally write this on your 4x6 card. You can totally write this, right? Put an example of one of these on there. There'll be one just like, there'll be a 4-termer. It's what I mean by it'll be just like this. There'll be one 4-term factoring problem with different numbers. And so when you but they're all mixed up. It won't be number 20. It'll be all mixed up. But there will be one 4-term factoring problem. So when you get to it, if you have the 4-term note written on your card, then you'll go, 2-2 split, take out the GCF, parentheses are always the same. So then the parentheses match. Now there's one more step though. We're not done here. Remember about you can't have the loose horses? That right there is a loose horse, right? You can't have minuses or pluses that are out loose and free. So what do we do from here? Yeah, do you see how they both have the same matching item? 3x plus 4. Remember that? Think about, what if you were factoring something like 2x squared w minus 5w? What would you look at those two and say they both have the same? W, right? And what would you do? You'd put it in the front. It would be what's in common. Remove it, bring down the 2x squared, bring down the minus 5, right? That w could go boom, boom, and go right back, couldn't it? That's a factoring we do all the time. Well, that's exactly what you do with the 3x plus 4. It's just a bigger, like, w thing, right? They both have a parenthesis 3x plus 4. So put a parenthesis 3x plus 4 in the front, just like you put a w in the front. Remove it, start a new set of parentheses, bring down the 2x squared, the leftovers, and the minus 5. There we go. There's the factoring. There it is, B. Yeah, but backwards order, but same thing. Does that make sense? All right.
So you consider that backwards? How they have it down?
Well, they have the reverse order of how I have it anyway. That's all I'm saying.
Oh, okay.
I put the 3x plus 4 first.
Oh, okay, because the way you have it, most times people just do 2x minus 5. That's their own thing. What's left over is 3x plus 4.
Sure. Either way is totally good.
And that's why they did it that way.
All right, so let's try 21. So 21, we're multiplying two fractions. That's going to be 4 factoring problems, basically, right? Well, one of them doesn't factor, but in the interest of time, I'm going to roll right along. So this up here factors z plus 6, z plus 6. Because it adds to be 12 in the middle, multiplies to be 36. This one right here, z plus 2, z minus 2. Because that makes, you got to have 1 plus, 1 minus to make minus 4. And this back here, take out a z, because they have z in common. That leaves z plus 2 over z plus 6. All right, so after all that factoring, then we just cancel what matches, huh? Z plus 6, z plus 6, z plus 2, z plus 2. So what are we left with? Z plus 6 on the top, along with a regular z, right, this guy. And on the bottom, z minus 2, you don't need this parentheses, z minus 2. There it is. Is it D? Yeah, it's D. Difficulty 2. 22. How do we do that one? What do we do? Remember, this is what we just did this week. Yeah, never subtract. Pop him right up there. So step 0. So this is all the steps we just did. Again, I'm going to kind of whip through it. I really need to get through this at this point to get on to something else. So this, and then factor this denominator. This right here is x plus 4x minus 4. Change to plus in the middle. Put the minus on the 5. Factor the other one. And it's going to be plus 4 plus 1. So remember, step 0 is never subtract. Remember that? You move the negative up like we did right there. Step 1 is factor denominators. That's what I did right there. Next step, remember what we do on these steps? Next step is we give them what they're missing, right? Multiply top and bottom, let's do it like this. Multiply top and bottom by what is missing. Multiply top and bottom by whatever's missing. All right, so we talked about comparing with your neighbors, right? So,
Missing the x minus 4.
yeah, so what is this first one? What is he missing that the other denominator has? He needs the x plus 1. So give him the x plus 1. And then you come over here to the other guy, and he needs the x minus 4. See how they both are the same denominators now? They have all the same 3 pieces. See how we made the denominators the same? That was last night's homework. I'm assuming you're kind of fresh on this. So then you just make it one. You don't need 2 fractions anymore. They are the same denominator. So make it one big denominator. Step 3, multiply tops and do the like terms stuff, right? On the top. So now we multiply the tops. That x is going to go boom, boom. X squared plus x. That minus 5, boom, boom. Minus 5x plus 20. And then we bring it down. Gather like terms. X squared plus 1x minus 5x. Negative 4x plus 20. There it is, answer B. We haven't had none of the above for a while. So we never subtract. Grab this, move it up there, so we get 2 over x plus 2 plus negative 2, right? That's the same thing. We're adding the opposite instead of subtracting. And then we come over here and give him what he's missing. What is he missing? He's missing what the other guy has. X minus 2. Let me make that a little bigger. X minus 2, right? And what's this guy missing? X plus 2. See how we've made both denominators the same? Common denominator. So now we don't need 2 fractions. They're the same denominator. Make it one big fraction. Multiply this. 2x minus 4. And multiply this. Minus 2x minus 4. That's interesting, huh?
Yeah.
The 2x's cancel. You get minus 8. Over x minus 2. X plus 2. Oh, it's none of these. That's a weird one, huh? And sort of disturbing at the end. 3 or 4? Was it 3? 3? Yeah, that's about right. Yeah.
Yeah, I was gonna.
Okay, good there. Questions on that? I'll rewrite it. 4 plus 2 over s. What number is it? 24?
Yeah.
I think this is the last one.
No, there's 2 more after.
Yeah, but
There will be more keys.
I don't think you're gonna give us.
Yeah, here's 18.
And s over 3 plus 1, 6. S over 3 plus 1, 6.
Is that S?
Yeah, let's make it an x, because my s's look like 5s. For the sake of Mr. Heron's amazing handwriting. All right, so there we go. Yeah, so remember what we do on these. We multiply. This is a complex fraction, if the name helps you. It's a complex fraction, meaning it's fractions over fractions. So what do? We multiply all the terms by the LCD over 1. But what's the LCD?
6.
The LCD, yeah. For the 3 and the 6, what if you had a denominator, what if you had 1/3 and 1/6? What would be the common denominator? 6, right? They both go into 6. 6, but you also need that x, right? So remember, when you form an LCD, you look at all the denominators, excuse me, x, 3, and 6, and you put them all together to form an LCD. Now, if you used 18x, it'll work. It's okay. It's not the end of the world. You'll have a little more simplification. 6x would be easier. That's actually the lowest common denominator. 18x will work, though. So either one. So, all right. Let's do 6x. Now, what do we...
That's the second method, right?
It's only one I showed.
What did you divide it?
There's 2 to... No.
No.
Multiply all 3 of them. That's the other method. That's what a lot of the tutors know, because they never know the else and B.
Yeah, you can multiply them all together and get 18x. That'll work. Yeah, that's okay. So so 6x will be a little more efficient. So okay, so what do we do with it now? We multiply that over 1. So 6x over 1. 6x over 1. 6x over 1. 6x over 1 to all the terms. And now we cross cancel, huh? So, well, first off, right here, these guys are just going to multiply because nothing can cancel. Why do I say nothing can cancel? Because there's not anything under the bar that, like here, these x's will cancel, right? So this is just 24x plus 12. Good so far. See what's happening? I just multiplied 4 times 6x.
Yeah.
These x's
It's
cancel.
really 4
6,
over.
12.
It's really 4 over 1. If you want to.
Right, exactly. That's a good way to say it. It's really 4 over 1. And so they multiply to be 24x. Over here, 3 goes into 6 2 times. 2, and how many x's?
1.
X squared. Right?
Wait, what?
Yeah.
That doesn't. Oh yeah.
2x squared, right? Good. Plus, these 6's cancel, x.
My answer is not there. It's wrong.
We good so far? Make sense that you're tracking with all that canceling? Okay, now, on the top, how do we factor the top? What goes into these two?
2.
12. 2x plus 1. Right, you got to find the greatest number that goes into them. So 2 goes into them, 3 goes into them, 4 goes into them, 6 goes into them, but 12 is the greatest number. It goes into 12 and 24. On the bottom, what goes into these guys? X. What does that leave behind? Same thing. X times 2x is 2x squared. X times 1 is x. And then what happens? Those cancel. 12 over x. Is that one there? Somewhere? 12 over x. We good there? Does that make sense? There's a lot of steps on that. So 25. Here's, well, here, let me move. A fourth p minus 3/8 p is 5. Fourth p minus 3/8 p is 5. Minus 3/8 p is 5. Okay. There we go. So this one's an equation. We're gonna solve it. This is not multiple choice. Did you notice back here? So the last two on the actual exam you take on Tuesday will be just like this. They're not multiple. It just says leave your answer below. It's not multiple choice. Doesn't go on the Scantron. Just work the problem right there. Leave your answer right there. I'll just grade it individually like that.
Is it only going to be 1 point like all the others?
1 point? No, they're all worth 4, right? Because 25 questions times 400.
So the ones that you have to.
They're all worth the same. 4 points each.
So technically, if I leave it off, I'll still get 92.
You get a 92 if you leave them both blank. You're perfect otherwise. All right. So how do we solve for p there?
That's math.
What do we do when we have denominators with an equal sign problem?
LCD.
Yeah, LCD. And what's the LCD of 4 and 8? What do 4 and 8 both go into? 8. LCD's 8, right? They both go into 8, don't they? So that's what you do. So you multiply 8, 8, and 8. You got to do the same thing, right? Left side, right side. It's an equation. You got to keep the balance, right? If they were equal before, you treat them the same. They'll still be equal, won't they? It's the principle of equality. Okay, so here we go. Can you do the next step? We're canceling denominators, right? take out those denominators. Sometimes I call it a hitman. Take out those denominators. So 4 goes into 8 2 times, 2p. 8 cancels 8, 3p. 5 times 8, 40. No more fractions. Right? You just cancel denominators. Right, 2p minus 3p? Negative 1p. What do you do to finish getting p alone? Divide by negative 1, or just change the sign, same thing. Negative 40. So you'll just leave that right on your paper.
Okay. I think people got confused by your face. You see the 8, write 8 over 1.
Oh, does that help? 8 over 1, 8 over 1, 8 over 1. Yep. Any whole numbers over 1. Right. Good. Question.
Everybody's like, what are you doing? Like,
Have a go.
Problems that we just did, the ones we have to actually write out on the quiz.
No, this one, 25.
25 and 26.
And now we'll do 26. Yeah.
So those are the ones on the quiz that we have to actually.
Yeah, so it's exactly like on the prac exam. So you see the prac exam, the ones that don't have multiple choice, same thing on the real exam. So here comes number 26 now. All right, so can you see that one okay?
Wait a minute.
It's our last one. And then we got to do some chapter 2. Dennis is dying to do chapter 2, he told me. Secretly. All right, I'm just going to whip it here. Boom, boom. Things outside parentheses. 6x minus 15. Parentheses drop. Right? And now, these two on the same side. 6x minus 4x. 2x. All right, what do you do now? Sometimes people get stuck right here. What do you do when you have x's on opposite sides? You do them first, by the way. You don't do anything with the minus 15 and the minus 3.
You have to
First,
get
do
rid
the
of
x's.
one.
What do we do?
You don't want to
Get rid of them?
Get rid of one of them. Exactly. Which one? It doesn't matter. Really, you can do either one. I usually get rid of the lower one, but it doesn't really matter. Just get rid of one of them. So this guy's lower. He's negative, huh? So I'll get rid of him. What's going to get rid of that minus 2x? Add 2x. What do you do to one side? You have no choice but do the same thing. They got to keep the balance, right? They were equal before. Treat them the same. They'll still be equal. These cancel. And so now, this is, 4x minus 15. X is in, I won't be alone. Add the 15, so x can be alone. Those cancel. 4x is, 12. 15 minus 3 is 12. Last step to get x alone. Divide by the 4. X is 3. So just leave that on your paper. Those last two, just like that. It's not multiple choice.